So today we're going to be starting chapter 10, which is the last chapter of the year. And chapter 10 is on circles, properties of them. We're going to write graph equations of them. This will be used later in Algebra 2. The last section is actually a lesson in Algebra 2. That will be just a little bit of an introduction for you now, so you can be good at it later. So 10.1 is a little bit of a review for you, but you need to know these parts so when we're talking about questions with them, you know what to do. So the first part of this, a lot of is vocabulary. So first of all, a circle is a locus or set of all points in a plane equidistant from a given point called the center. Okay, so here's your center. It's labeled with a letter. And a circle is points that are all equidistant from this. Okay, so all those points on the circle are equidistant from the center. Notice how they label it. It's either circle C, so it's always labeled with the center, or this little shortcut, this symbol, is also represents circle. Okay. A radius, plural radii, is a segment with endpoints at the center and on the circle. So it's on the center and on the circle. So an example with those are CF is a segment. Notice it's a segment. So notice how they're labeling that. CE is a radius, and CD are a radius of that circle, because they all start at the center, endpoints on the edge. A chord is a segment with endpoints on the circle. So a chord has to only have endpoints on the circle. So AB, notice there's two endpoints on the circle, is a chord, and so is DE. They have two endpoints on the circle. A diameter is a fancier chord. Okay, so a diameter is a chord, but it passes through the center. Okay? So the definition of a diameter is a chord that passes through the center. Okay. Circle pairs. You know two circles are congruent when they have the same radius. So GH and JK are congruent circles because their radius are the same. Similar circles, all of them are similar. So that's not too hard to do. And concentric circles are coplanar circles that have the same center. So this would be circle A, would be here with radius AB. And then circle A with radius AC are here. These are concentric because they share the same center. So they look like a bullseye. Inscribed and circumscribed. So a polygon is inscribed in a circle if all its vertices lie on the circle. So inscribed is inside. So notice the vertices are all inside the circle. Okay. Or on the circle. A circle is circumscribed without a polygon if it contains all the vertices. So you would say the polygon's inscribed, but the circle is circumscribed. Okay, it's outside the polygon. Circumference, you already know this formula, but just to remind you, highlight this one. You've already seen this one before, but circumference is the distance around the circle. So it's either pi times diameter or 2 pi r. So as far as examples, a lot of it reminds me of chapter 1, really, when you're trying to identify certain parts of shapes. So it says identify a chord and diameter of a circle. So a chord, once again, are segments that have endpoints on the circle. So I'm going to say all of them. So one of the chords would be WZ. Make sure you put a segment line over that. Another chord with two endpoints on the circle would be WY. And the last one would be XZ. Because they all have endpoints on the circle. A diameter is a fancier chord. So a diameter is a chord that goes through the center. So there are two chords that are listed that go through the center. One is WY, and the other one is XZ. These are kind of fun. They're like little puzzles. So the diameter of circle X is 22, diameter of circle Y is 16, and WZ is 5, and you find XY. So you're going to use like the addition property of equality to kind of figure this one out. So I like to label this picture. So circle X, the diameter of circle X. So circle X is here. So you find the center, and that would be the circle. So if the diameter is 22, like the segments that they have labeled here, it's not a diameter, like this length is really a radius. So I know to cut that 22 in half, and that's going to be 11. So I do the same thing for the other one. So the diameter of circle Y is 16, so here's Y. So here's Y, and then here's the circle. So a diameter is that, but then this is really what they have labeled here. So that green part, that's 16. It doesn't really look like it, but that's okay. But actually not 16, that's the diameter, so it's not really 16, that would be 8. So you have to cut that in half. And then the last one, they give me WZ is 5. So this little bit in the middle is 5. So I need to find XY, so that whole segment. So they give me a ton of information. So a couple ways you could think about this. I know from just here to here is 11, but now I just need that last bit of green, but there's this overlap. So this blue is 5, and then the whole part is 8. I know this little bit is 3. So to find XY, that's going to be 11 plus 3, or 14. And then do this. Right, so here's another one. So we have diameters of F and G are both 5 and 6 respectively. So F is 5, the diameters are. So here's F, here's the circle with F. So if the diameters are 5, that means the radius is 2.5. So I'm going to label this whole thing, that's 5. So I'm just going to label all that. So that's 5. Then we have circle G is 6. So here's G. Thing. So that with the green is 6. And then find each measure. Then you find BF. So the BF is just a little bit here. Okay, well, I know, so I have to be creative here. The diameters of the green is 6, so this part here would be half of that, so that's 3. And then the circle F, okay, from here to here, this length is half of 5. So half of 5 is 2.5. So this whole bit is 3, and the other part is 2.5. I know that BF would have to be 0.5 units. And then AB, so this is 0.5. I'm going to erase some of this stuff here. So I need to find BF now, or AB I mean. Well, I know that FA, that's the radius of the red one, and that's half of 5, so that's 2.5. And we just said this little chunk here was 0.5. So what I'm going to do is, take 2.5 and subtract the 0.5, so AB is 2 units. They're like little puzzles. Hey, coins, 3 identical circular coins are lined up in a row shown. right? So the distance between the centers of the first and third coins is 3.2 centimeters. What is the radius of one of these coins? Okay, well, what I kind of want to do is, okay, so if these are all the same, then that means all the radius are the same, or radii are the same. So let's back up. Let's figure out like what each section is. So if all their radius are the same, I have how many radius here? I have the 1, 2, 3, 4. So I know 4 radiuses, radii make up 3.2. So if I want to find one of them, I'm going to divide both sides by 4 to figure out the radius of one of them. And when I do that, I get 0.8 centimeters. Okay, find the circumference. All right, so in this exactly what this formula is. So circumference is 2 pi r or pi times diameter, whichever one you want to use. So using the fact that these are both radius, okay, we don't have any of them. So we're going to have to figure those out. And if you notice, these two lengths are the same. So if I were to write this out here, if these are the same, that makes this a 45, 45, 90 triangle. And then 3 radical 2, I can use my 45, 45, 90 rules to figure out the lengths of the sides. So I can divide by radical 2, which is now 3. So I know both those sides are 3. Well, that's what my radius is. So I figured out my radius is 3, so then to find the circumference, I go 2 pi r, which is your 3, so 2 pi times 3 is 18.8 units. Circumference is a length, so it's not units squared or cubic, it's just units. Okay, well this is the same kind of deal. We have, I don't know the radius, okay, but at least I know that these two lengths are the same. So if I were to redraw this here, it's just like the last one. These are the same because they're both radius. These are both 45. So remember, to go from hypotenuse to a leg, you divide by radical 2, so you can write that out. So remember, that's when you rationalize, you multiply by the weird looking 1, you get 10 radical 2 over 2, which reduces to 5 radical 2. So that's what my radius is. So to find my circumference, I take 2 pi radius, 5 radical 2, and type that in my calculator, and I get 44.4 units. Seven. Okay, so circumference 2 pi r, or pi times diameter. So I don't have that. I do see some right triangles though, so let's look at this here. There's a right triangle. And it looks like I'm going to find my diameter, because this goes through the center, and it's endpoints on the circle, so I'm going to try to figure out D. Well, if that's D, I can, if I scoot up this 15, and maybe if it, kind of see if I were to redraw this here, I can use the Pythagorean theorem to find out what my diameter is. This is a triple. It's not one as well known, but if you didn't know what the answer is, you can solve for D, and you'll get 17. But that is a triple. So then to find circumference, I'm using the pi times diameter formula, just because that's what I already have. So I'm going to go pi times 17, and I get 53.4. And the last one, we have to find circumference. This one is just kind of using what you know, like, if I take this 11 yards and scoot it over, parallel. If I were to scooch this over, see where it would land? It lands right on the diameter. So this is 11 as well, 11 yards. So I'm going to use that same formula for circumference like I did on the last one and plug in my diameter of 11 yards. And when I type that in, I get 34.6 yards. And that is work with chords and circles.